In this tutorial, we are going to solve examples on integration by parts. So straight away we have this example. So my solution, do we have the formula for solving integration by parts, which is integral of u dv should be equal to uv minus integral of v du. So here there's a polynomial, so I'll let my u equal to the x, my du dx will be 1. Therefore, du will be equal to dx. Are we okay? And from here, my dv is sine 3x. To obtain v, I'll put the integral over there, and my v, integrating sine 3x is going to give you negative 1 on 3 cos 3x. So I have my u and I have my v. So which is now integral of x sine 3x will be equal to, using the right hand side, my u is x multiplying v, negative 1 on 3 cos 3x minus integral of v, which is also negative 1 on 3 cos 3x du, now equal to what? Dx. Are we okay? So we'll bring our dx. We can rearrange the terms so that we will get it in a proper manner. Here I can get negative 1 on 3 x cos 3x. Then this is a constant. I'll bring it out because it carries a negative. It will affect this negative, getting a positive 1/3 integral of cos 3x dx. Can I further solve integral of cos 3x? Yes. So which is equal to negative 1/3 cos 3x plus 1/3 into bracket. If you want to integrate cos 3x, that is going to give you 1/3 of what? Sine 3x plus your c. So finally our answer is negative 1/3. Here it is supposed to be x. 1/3 x cos 3x. Now you multiply through, which is going to be plus 1 on 9 sine 3x plus c. Someone may say 1 on 3c, which is the same as a constant, plus what? C. Therefore, this is the integral of this function. Very simple. Let's go to the next example. So, find the integral of x squared e 2x. So, we are to solve this. Solution. Since there is a polynomial function, I will let my u equal to x squared. Now du dx is 2x, meaning this is with respect to what? Dx. Meaning my du will be equal to 2x dx. Are we okay? So do I have mine? We already know our formula. So my dv is going to be the exponential function e2x, integral. Therefore, my v is going to be, when you find the integral of e to x, you have to differentiate the top, which is what? 2, and divide it. So that 1 on 2 e2x. So that's the integral of that. Now we can start with our formula uv minus integral of v du. And now that is going to give me, my u is x squared. Are we okay? Multiplying my v, which is half e2x minus integral of my v, and that is half e2x Now du from this formula is now 2x dx, multiplying 2x dx. So rearranging, I'm going to get x squared e 2x on 2. I'll factorize, or this 2, look at here, this half will take care of the 2 here. So in all, I'm going to get negative integral. I'll be left with x and ex dx. What do we see? Can we integrate this part alone and get one function? No, we have to. What do you see from this place? This place is also in the form of a product, integration of a product, the same as this question. So we have to treat this part as also integration by parts by going through the same approach, by keeping this answer. Do you understand? This is now serving as a question again where we need to integrate this part, but we can only do that using integration by parts. So we have to solve it that way. So from this side, let my u be x. Are you okay? Du dx will be 1. Therefore, my du will be equal to my dx. Are we good? Let me separate it. Now, from this side to my dv will be e2x integral. Therefore, my v, what's supposed to be my v? The same thing, 1 on 2 e2x. So we are going to plug in the values and solve for only this part. But remember, we have this as part of the answer, but just that we are solving only this part. So from this part, from the integral of x e to x dx part, then using the formula for integration by parts, I'm also going to get my u, which is x. So that will be x, right? Multiplying v, which is half of what? e2x on half minus integral of v, 1 on 2 e2x. Now, from the formula du, but here du dx is equal, so that will be dx. So I'm getting x e2x on 2. This half will come out minus half integral of e2x dx. Now, when you look at this point, I can integrate this alone. The reason I couldn't do here was x was attached, so I have to solve it integration by part again. But now I'm having only e to the power of 2x. I can integrate, and it is going to be e2x on 2 minus half of, when you integrate this, you are going to get another half of e2x plus c, and that is going to give me x e2x on 2 minus, are we good, minus 1 on 4 e2x plus c. So this answer is just from this part, but the entire answer combines these two. Are we okay? And there's a negative attached. So therefore, the original answer is going to be, you include this part, which is x squared e2x on 2. This negative will run through the answer you got for this, and this is the answer. So negative, this negative is going to what? Affect it, which is going to be negative this x 2x on 2. Then the negative will affect this, which will be plus 1 on 4 e2x. Whether negative c or positive c, this is a constant, plus c. So this is the final answer for that integration question. Are we okay? It's very simple. You just have to know what you are doing. You go through the process. Then we got here. This is where the problem lies. We got here. We saw that inside the integral sign, there's another product which we cannot do anything about it. Supposing here was only x, we could have solved it and get the final answer, but here is another product similar to the question. So you have to use another integration by part again, go through the process from just this point, get an answer for this part, combine the entire answer. So you can see that when x is squared, you are going to do the integration by parts 2 times. If it is cube, you are going to do it 3 times. Are you okay? Because we are going to let your u be x. So the number of power of the x is also going to affect the number of integration you are going to do. So let's look at a situation where this is cube. We are going to do it 3 times. So example 3, integral of x cube cos 2x dx. So this is the question. Here, quickly, polynomial and a trig function, let my u be x cube, then my du dx will be 3x squared. So du is now going to be 3x squared dx. From here, I can say my dv is equal to cos 2x. Therefore, applying integration to get my v, I'm going to get, when you integrate this, that will be half sine 2x. So with the integration formula from uv minus integral of v du, this, I'm going to solve for the first part. My u is x cubed multiplying v sine 2x on 2 minus integral of v, which is half sine 2x du, but du is 3 times x square what? Dx. Are we good? So here, if I'm going to rearrange it, I'm going to get x cubed sine 2x on 2 minus, so this, there's a 3 and there's a 2 here, so I can factorize them out, giving me 3 on 2 integral. This will be left with x squared, and I'll be having sine 2x dx. Can I integrate this part alone? I have to also use integration by what? Parts. So this is my first equation, but still there's a product in the integral or with the integral, so I have to consider this part. So from this part, we are also going to apply a different approach. Let's go. So from integral of x squared sine 2x dx, I will let my u be equal to x squared du on dx 2x. Therefore, du is 2x by what? Dx. Here too, my dv is sine 2x, meaning my v, which is integral, is going to be, what will be the integral for sine 2x? That will be negative 1 on 2 cos 2x. So can I rearrange or solve according to the integral formula again with only this part taken from the first part of the answer? Yes, I can do that. So what do? We have to bring in the values. Let's maintain this 3 on 2. After getting the answer of this, we will multiply through by the negative 3 on 2. Are we okay? So then I'm going to get from the formula u, which is x squared on v. So this is going to be multiplying a negative 1 on 2 cos 2x, right? Minus integral of v. which is the same as negative 1 on 2 cos 2x du. But here du is also 2x dx. You have to pay attention from this side. So can I move to a different page? So we have to simplify this. Let me simplify it here so that we can use it. From here, can I get a negative x squared cos 2x on 2? This side, the negative is going to be what? Affected, because here is already negative. These two can also cancel these two out, giving us what? A positive side. Is that true? So these two will cancel these two. So I'm going to get plus integral of leaving x cos 2x dx. So this is the part. After taking only this part, we are also arriving at this answer as negative x squared cos 2x on 2 plus integral of x cos 2x was dx. But looking at here again, there is another product. This is interesting. There is another what? Product. Or I can also bring this whole thing, this whole answer in place of this, so that this negative 3 on 2 will also do its job before we can start what? Processing. Okay, so remember this negative 3 on 2 will come and multiply this to be positive 3 on 4 cos this, and the negative will still affect this. So the answer will be equal to, you can check, go back and check, which will be equal to, if I'm going to include all the first answer, let's include this with that and with the answer for this. That is going to give me s cubed sine 2x on 2. Then this is the negative 3 on 2. And the answer for this part, is that it is negative x squared cos 2x on 2 minus, let's check, or we've solved it already, plus root of x with respect to what? That. So we already have that. X cos 2x. Dx. Are we okay? So let me multiply through so that I can get the final answer from this side, and we continue what? With our solution. Are we okay? That is going to be s cubed sine 2x on 2 minus 3 and this, so plus 3 on 4 x squared cos 2x. This is now going to also give us negative 3 on 2 integral of x cos 2x dx. So this is where we've read this, combining everything. We are now here. But looking at this again, it is another product. So we have to go for the last part. So what do you see? You can see that gradually it will be decreasing from x cubed now to, we go to x squared. Are you okay? And before, so from x cubed here, we solved for x squared, and now it is in terms of what? X raised to the power 1. So we are going to do it 3 times. So here, from only the integral of x cos 2x part dx, I can also say let my u be x. Du dx is equal to 1. Therefore, du is equal to what? Dx. My dv is cos 2x integral. Therefore, my v is now going to give me 1 on 2 sine 2x. Can I put them inside to solve this part? So our focus on this part alone. We keep all these answers, combine the answer of this part also. So my u, which is now x, and my v, which is this. So when you combine the v and the u, you're going to get x sine 2x on 2 minus integral of v, which is 1 on 2 sine 2x du. Now du is also equal to what? Dx. There is 2, there is 2. So can I do something about it? Yes, we can cancel the 2 out. No, sorry, this is just sine 2x. So we have to factorize the 1 on 2 out and we solve. So x sine, it is very confusing if you don't pay attention, minus this 1 on 2 is going to come out, integral of sine 2x dx. So we can now find the integral of sine 2x dx. Are we okay? So this is going to be x sine 2x on 2 minus this again. When you solve this, it is going to give you 1 on 2, the integral of that, negative 1 on 2 cos 2x plus c. So if I multiply this through, that is going to give me x sine 2x on 2 minus, so plus 1 on 4 cos 2x plus c. Remember, this answer is the answer for this part, so we have to combine it with all this, and there's a negative 3 on 2 also here, which will have to take effect throughout. Are we okay? So combining this with that, our final answer from this part is going to be, this is interesting. So our final answer is now going to be s cubed sine 2x on 2, that's this part, plus this 3 on 4 s squared cos 2x plus 3 on 4 x squared cos 2x. This negative 3 on 4 is going to, 3 on 2 is going to multiply the entire answer here, which is going to give us negative 3 on 4 of x sine 2x. This will give negative 3 on 2 by 4, 8 cos 2x. So this negative 3 on 4 x sine 2x, then minus 3 on 8 cos 2x plus c. So this is the final answer for the integral of s cubed cos 2x dx. Interesting. So this is the final answer. So imagine you are getting x raised to the power 4. Let's say sine 2x. You are going to get a long answer that is going to be 4 times integral. Are you okay? So go through the video step by step, check your answer and understand.